The telescope that broke the universe, INTRO, a shaken cosmos. For over a century, the laws of physics stood firm, monuments to human understanding, built brick by brick through observation, experimentation, and mathematical elegance. We believed we had cracked the code of the universe. We thought we knew how galaxies are born, how stars ignite and die, how matter organizes itself under the invisible hands of gravity and time. These weren't just theories, they were the bedrock of modern science. We taught them in classrooms, coded them into satellites, used them to simulate the birth and death of galaxies, and to predict the final moments of the cosmos itself. Then the James Webb Space Telescope opened its golden eye and looked into the oldest light in existence, and it didn't confirm our brilliance. It exposed our ignorance. A time machine with a shocking payload, Webb wasn't built for pretty pictures. It was engineered as a time machine, capable of peeling back the layers of the universe and showing us the very first flickers of light. When it aimed at what seemed like a blank, unremarkable patch of sky, it saw something extraordinary, a shining object, bright and structured, piercing the cosmic darkness like a lighthouse in a storm. Astronomers initially assumed it must be relatively nearby. After all, nothing from the early universe should appear that bright. But when the redshift data came back, it floored everyone. This galaxy, now labeled CEERS 93316, wasn't just far away. It was ancient. Its light had traveled across 13.6 billion years. That placed it just 230 million years after the Big Bang. And yet, what we saw wasn't a messy cloud of forming matter. It was massive, structured, mature. A galaxy that had already lived enough to organize itself into order. In simple terms, it had evolved. This was like finding an adult human in a hospital maternity ward. It wasn't just surprising. It was impossible, if our current models are correct. More than an outlier, scientists hoped this might be a fluke, an anomaly. But Webb wasn't done. As it scanned more regions of space, it found other galaxies, dozens, exhibiting the same unsettling traits: too large, too mature, too early. Some of them rivaled the Milky Way in mass, yet they existed at a time when matter was still supposed to be cooling down. According to the standard timeline, the universe was still a radiation-filled haze. Star formation should have been only just beginning. Instead, we were seeing galaxies that had not only formed but had already exhausted their gas supplies. They had burned bright, fast, and were already aging. Worse still, these weren't isolated miracles. They were part of clusters, suggesting that massive cosmic structures were already forming, billions of years earlier than they should have. Either our timeline is broken, or the universe has a mechanism we've completely missed. The edge that should not be visible. Then things got even stranger. Some of the galaxies Webb detected seemed to exist beyond the Hubble horizon, the theoretical limit of what we can see in the universe due to the finite speed of light and the expansion of space. By all rights, this light should not have reached us yet. And yet, we see it. Which raises an uncomfortable question. Is our understanding of the shape, speed, and size of the universe wrong? The Hubble horizon is supposed to define the edge of our observable universe. But Webb is peering past that edge, suggesting that either the universe is expanding differently than we thought, or the fabric of spacetime is far stranger than we ever imagined. Imagine standing at the edge of a canvas that keeps painting itself faster than you can look. You're not just watching the past, you're staring into an impossibility. The shaking foundations of physics, as the images piled up, astronomers began to do what scientists always do: measure, calculate, simulate. They estimated the mass of these early galaxies, the amount of gas and dark matter needed to form them, the star formation rates required to produce what Webb observed. And the numbers didn't just fail to add up. They broke the calculator. Some galaxies appeared to have the same mass as the Milky Way, yet had only hundreds of millions of years to form. That's like building a city overnight with no tools, no raw materials, and no plan. And the deeper Webb looks, the more our models fall apart. We used to think the Big Bang was the solid starting point of everything. Now, it's starting to look more like a rough draft. A patchwork of guesses and approximations that might have made sense with older data, but cannot survive what we're seeing now. To be continued, the James Webb Space Telescope was built to confirm our greatest theories. Instead, it may be demolishing them. And this is only the beginning. Because what Webb is showing us goes far beyond galaxies. It's beginning to question the very nature of dark matter, time, and even reality itself. In Part 2, we'll explore how dark matter is cracking under pressure, how time might be broken, and how deep field images may hint at a universe that's not just being observed, but observing us back. Stay with us. Dark matter, time, and the watching universe. Recap. The universe in crisis. The James Webb Space Telescope has peered into the earliest epochs of the cosmos. And in doing so, it has shattered nearly everything we thought we knew. Galaxies that shouldn't exist. Light from regions that should be unreachable. A timeline that collapses under scrutiny. But those were only the surface cracks. What's coming next may fracture the entire structure of modern physics. Dark matter. Ghost or glitch? For decades, dark matter has been our answer to the unexplained. An invisible scaffolding, making up 85% of the universe's matter. It explained why galaxies hold together. Why cosmic structures form the way they do. But now, Webb is throwing a wrench into that idea. The galaxies it's finding, ancient, massive, and dense, require either impossible quantities of dark matter, or they formed through some other, unknown force. In some cases, the required density of dark matter would have collapsed these galaxies into black holes. In others, they're forming in regions where dark matter should be too sparse. This isn't a simple error in simulation. It's a foundational contradiction. If dark matter behaved differently in the early universe, we need new physics. If it didn't exist at all, we need a new universe. When time breaks down, even more unsettling is what these galaxies say about time. Some of the stars in these galaxies appear older than the universe should have allowed. They look like they've had billions of years to evolve, but they're shining just hundreds of millions of years after the Big Bang. This isn't just strange, it's a paradox. Some physicists now believe that time itself may not be a fundamental property. That it may emerge from entropy, not govern it. Think about that. Time, what we experience every second, might be more like a side effect than a law. Not a river flowing forward, but a fog, thick in some places, swirling backward in others. If that's true, our entire understanding of cause and effect might collapse. And maybe, just maybe, the early universe didn't follow our rules. Because it wasn't bound by time as we know it. Stars from another script. Webb also seems to have captured hints of the universe's first stars, so-called population 3 stars. They were thought to be massive, metal-free, and short-lived. But no one had ever seen one, until now. Or at least, something very close. These stars are too hot, too massive, and too chemically primitive to fit into known fusion models. Some scientists speculate they may not be stars at all, but failed black holes that ignited in an exotic, unknown way. If confirmed, these stars could rewrite what we know about nucleosynthesis, the formation of elements. And perhaps even the life cycles of stars. But more importantly, they raise a chilling question. Are we witnessing processes we have no words for yet? No math for yet? No mental framework for it all? The structure of mystery. There's one final mystery Webb may be whispering to us. In its deepest field images, patterns have begun to emerge. Symmetries in galactic spin. Repetitions in cluster structure. Alignments that stretch across billions of light years. Too consistent to be random. Too large to be coincidence. Some theorists are quietly wondering if we are seeing evidence of something deeper, a hidden order behind the universe. Could the cosmos be generated rather than chaotic? Could it be engineered? Is this the fingerprint of a simulation, a quantum consciousness, or a universe that responds to its own observation? Are we being watched? The universe speaks back. What Webb has revealed isn't just the ancient past. It's a mirror, one that reflects the limits of our knowledge and the arrogance of our certainty. We built models. We wrote equations. We thought we had figured it out. But the cosmos had other plans. And now it's showing us that what we thought were answers were just placeholders. Maybe the universe was never meant to be understood. Only witnessed. And maybe, now that we're looking deep enough,